Alright, so on C, the first thing I notice is that this time, unfortunately, I am not just going towards one number because it doesn't look like I have a horizontal asymptote where both the left and the right approach. Why does that happen? Well, again, we would use that in behavior model, which would be x squared over 2x, and that is when I would just get x over 2, and oh crap, now my numerator is growing faster than my denominator. So that means that I would have no horizontal asymptote in this case. So in this case, I would actually have something called a slant asymptote. All right, so we did just talk about, synthetic division and long division a little bit, more so synthetic division is what we just got out of. But let's bring back some long division just for funsies, because I've got to use it in this case. So what I would have is I would actually have 2x plus 5 divided by x squared minus 4. And just for funsies, just to keep my terms lined up, I'm probably going to put 0x minus 4 in there. Okay, and a lot of us are like, well, why can't you just use synthetic division? I don't have a singular x out in front. I have a 2 out in front of that x, so therefore I can't use synthetic division. It's kind of unfortunate, but it's what happens. Alright, from here I'm saying, okay, what do I need to multiply 2x by to get me an x squared underneath? Because that's the first term that I need to get rid of in order to divide. Just like if I was dividing 96 divided by 3, I would have to say, okay, well, the first number I would have to deal with is this 9, so what would I have to multiply it by 3 by to get that 9? Well, that would be 3, and then I'd multiply 3 by 3, I'd get a 9, and I would subtract straight down. Synthetic, or long division, works the same way with algebra as well. So I'm saying, what do I need to multiply 2x by to get me x squared? Well, that would be a 1/2 x, because that half would get rid of the 2 out in front of the x, and then x times x would give me x squared. So then I would get x squared plus 5/2 x. Alright, well, that's going to be icky, but it's not as bad as we think, because the x squareds would go away. And then I would just have minus 5/2 x minus 4. And then I'm like, what do I need to multiply that 2 by to get 5/2? And that becomes a little bit grosser. So I know that I'm going to have to multiply a positive times a negative in order to get rid of that negative when I subtract straight down. And then in the next part, I gotta say, okay, well, what do I have to multiply 2 by to get to 5/2? Well, that would actually be 5/4. That way, when I multiply 5/4 times 2, well, I'd take 5 times 2 and get 10, divide that by 4, it would reduce down to that 5/2 that I want it to. And when I multiply by an x, I'm automatically going to get that x sitting there, so I get negative 5/2 x, and then I get 5/4 times 5, which is going to give me 25/4. Alright, and then I subtract straight down, and we're ready to rock and roll. So then those are going to cancel. I'm probably going to end up changing that to 100/4. So I should get... If you need to write it out of what the heck I'm saying, all I did was change the whole number to a fraction, so that way I can easily actually subtract them. So I should get, what, negative 75/4? Alright, and that's gross. That's my remainder, because I'm never going to be able to multiply something by x and get something without an x. Alright, so what this turns into is I would have this remainder of 75/4, but the nice thing is that negative 75/4 would actually be over 2x plus 5. Well, in this case, my denominator would grow significantly faster, so that remainder, which is as gross as it is, it's basically not going to matter, because if our denominator grows faster, that piece is going to go towards 0 as I plug in bigger and bigger numbers. So really, the only thing that I give a crap about is the stuff up here. So my slant asymptote is just at y is equal to that 1/2 x minus 5/4. Okay, why does that help us out? Well, as I'm going towards infinity, as I plug in bigger and bigger numbers in for x, that means that my value is going to go towards infinity as far as my y's go. So I've got the limit as x approaches infinity, and that piece is going to get bigger and bigger and bigger as I plug in bigger and bigger numbers in for x. So that's why that piece is going to go towards infinity as far as y values go. Alright, but what if I plug in the limit as x approaches negative infinity, which means that I'm approaching big freaking negative numbers? Well, eventually this particular bit's going to get larger than 5/4, and it's going to go ahead and be a negative number. And again, we can see that on the graph. So as I go to the right, my y values are going up and up and up forever. And as I am going to the left, my y values are going down forever. As my x values go left forever. Alright. And then the other gross thing that we got to deal with is this lovely little split here. So I'm like, okay, well, I know that my asymptote, looking at the denominator, it's not going to cancel out with anything up top, which is kind of unfortunate, but that's okay. I can say, okay, 2x plus 5 can equal 0. So then I'd say, okay, 2x cannot equal 5, so x cannot equal negative 5/2. And that's about where my asymptote is. That's actually exactly where my asymptote is. So it can't equal negative 2.5 if you guys prefer decimals, which means that I need my limit as x approaches 2.5 from both sides. Well, from the right hand side this time around, that is going to approach positive infinity because it's going up and up and up forever. And then from the left hand side of that particular x value, my y values are going to go down forever, which means that it approaches negative infinity. So my limit as x approaches 2.5 from the right should be negative infinity, and from the left it should be positive infinity. And that's all. This is probably the hardest problem we will see. I'm not going to give you guys too many with asymptotes. I'm just letting you guys know, hey, this is how we find them. We did just talk about synthetic division. So let's bring back a little bit of long division to be like, oh yeah, that's a thing, and that's why I wanted to avoid it. But here it is. Alright, I'll see you guys in my next video.